Hello viewers, how are you? With the hope that you all are fine. In this video, we will be discussing about uses of magnetic permeability denoted by mu. First of all, let's recall what is magnetic permeability. I am sure that you are familiar with magnetic flux density denoted by B and magnetizing field strength denoted by H. Magnetic flux density is a measure of actual magnetic field within a magnetic material, considered as concentration of magnetic field lines or flux per unit cross-section area, whereas magnetic field strength is a measure of magnetizing field produced by electric current flowing in a coil of wire. The role of magnetic permeability begins from the relation of B and H as B is equal to mu times H. Thus, magnetic permeability, or just a permeability, is the degree of magnetization that a material obtains in response to the applied magnetic field. It can also be defined as the measure of resistance against the formation of a magnetic field. In most cases, permeability is measured as relative permeability, given as mu r is equal to mu by mu naught, where mu is equal to absolute permeability of the material and mu naught is permeability of vacuum, which is equal to 4 pi into 10 to the power minus 7 Newton per ampere square, or Henry per meter. In some cases, it is also taken as magnetic susceptibility by the relation chi m is equal to mu r minus 1. Magnetic susceptibility denoted by chi m is a dimensionless quantity, and it is a measure of how much a material becomes magnetized in response to applied magnetizing field strength. Mathematically, chi m is equal to m by h, where m is magnetization and h is magnetizing field strength. Now let's discuss the uses of magnetic permeability in daily life. 1. To distinguish magnetic substances. Value of relative permeability helps to distinguish the magnetic substances. For example, if mu r of material is less than 1, then this is diamagnetic substances. For example, water, glass, etc. If mu r of material is equal to 1, then there is actually no material, that is vacuum. If mu of material is just greater than 1, then this material is paramagnetic. For example, aluminum, magnesium, etc. If mu r of material is very greater than 1, then this is ferromagnetic material. For example, iron. This helps the industries to select good magnetic material to produce devices of daily use such as dynamo, electric motor, coil of transformers, etc. 2. To calculate magnetic field due to current carrying conductors. Biot-Savart law is applied to calculate magnetic field intensity due to current carrying conductors, where permeability is also used. For example, magnetic field intensity at center of a circular current carrying conductor of radius r with current flowing I is given as B is equal to mu naught I by 2 times r. For more examples, you can check out Biot-Savart law in magnetism. There are Ampere's circular law and Helmholtz law to calculate magnetic field strength due to different types of current carrying conductors. You can check out them at Google. If permeability of material is not considered, these laws cannot provide precise value of magnetic field strength. 3. To calculate force between current carrying conductors. If you are thinking of calculating force between two current carrying conductors of certain length, then you have to take into account the role of permeability. For two conductors having same length L separated with distance r, carrying current I1 and I2, the force between them is F is equal to mu naught L times I1 I2 by 2 pi r. From this, you can predict the directions of force and magnetic field strength. You can also say conductors repel or attract each other. If like current pass through conductors, they attract each other. Opposite is true for unlike currents. 4. To calculate the inductance due to current flow. Inductance is the process of inducing electric field in a coil due to the flow of current in itself. That is self-inductance, or any other conductor near it, mutual inductance. Self-inductance of a coil of cross-section area A, number of turns N, and length I is given as L is equal to mu naught times A into N square by L. Inductance is independent of current flowing in the coil. Inductors having suitable inductance are used in almost all electronic devices, for example, television, radio, mobile, laptop, etc. 5. To calculate the speed of light. Permeability is also used to calculate speed of light in vacuum, as C is equal to square root of mu naught epsilon naught, where epsilon naught is equal to 8.85 into 10 to the power minus 12 coulomb square per Newton meter square. This is electric permittivity of vacuum. For medium, both permittivity and permeability are taken as their relative values. In 5 examples mentioned earlier, permeability of vacuum is used. For real applications, medium is present, for which corresponding relative permeability is used. Ferromagnetic material having high permeability is used for making storage devices such as pen drive, hard disk, recording tape, etc. These uses show that permeability is so useful in our daily life. The device on which you are watching this video is also using concept of permeability because it contains magnetic materials. That's all for this video. We will see you in next video with next topics. Till then, like and share this video with your friends. Also subscribe the channel so that you will get notification of our next videos first. At the end, thanks for watching. Please stay at home, stay safe and stay connected with us.
Please click on subscribe button and press the bell icon so that you never miss new updates of this channel.